Well, the time has come, ladies and gentlemen. It's for one more great interview of DojoLIVE, connecting experts like you. Well, today we're very, very, very honored to have here as a guest, Mr. Vint Cerf. Vint is Google's chief internet evangelist, and he's going to be chatting with us today about specifically the internet. So what's beyond the 2020s? Now what, right? Unfinished tasks as the internet reaches 50% penetration of the world's population. Vint, it's an honor to have you here, and we look forward to this conversation.
Well, so do I. It's really a pleasure to talk with you and the folks who are on the air with us.
Absolutely. And of course, as ever, I have here on the other end my fellow teammate and Usopian, Tulio Siragusa in Los Angeles. Tulio, how you doing?
Hey, good afternoon. Very excited to be here today. Super, super excited to have Vint as a guest.
Exactly. Same here. And I'm sure that all the folks that are watching out there, and which are, they're increasing by the second now. So I'll give you all the figures and the numbers in a few minutes. Okay. Well, Vint, I would like to start off by, of course, I'm sure that there's very little that could be said about Vint Cerf that has not been said. But I would like to just take advantage of this opportunity to ask you just a couple of questions to begin with. Tell us about you and your role at Google, and then why you chose this particular topic. Let's start with that. Again, thank you, Vint. This is Carlos Ponce at Nearsoft in Mexico City. Welcome to the show, Vint.
Thank you very much. I'm delighted to be here, as you can imagine. So the simple story is that when I joined Google in 2005, they originally said, "What title do you want?" And I said, "How about Archduke?" And Larry and Eric and Sergey went away, and they came back and they said, the previous Archduke was Ferdinand, and he was assassinated in 1914, and it started World War I. So maybe that's a bad title to have. Why don't you be our chief internet evangelist? I said, okay, I can do that. My task in writ large is to get more internet built all around the world. And so by December of this year, internet will have penetrated about 50% of the world's population, which means I have another 3.7 billion people to convert. So I was told I can't retire because I'm only half done. The reason that this topic is important to me is that getting more internet out there is actually a non-trivial exercise, especially as you go out into the parts of the world where disposable income is reducing. Costs have to be driven out of the service so people can afford it. And so they can participate in programs just like this one, among all the other myriad things that we've learned to do on the internet. So I care a lot about that topic. Fortunately, in the position I'm in, I have leave to interact with almost all parts of Google. So I've been part of the research team, part of the policy team. I spend time working with some of the Google alphabet, I should say the alphabet companies, of which Google is one. So it's a very broad portfolio. I travel a great deal. I do a lot of public speaking. And this is, of course, part of that. So the topic that I picked in particular, though, has to do with trying to understand what's happening to the internet now that it's about half penetrated, and what are the unfinished things that we still need to be worried about. And I hope in the course of our conversation, we'll explore some of those things and maybe even excite some of your listeners to try solving some of the problems that still remain in this gigantic infrastructure, this global infrastructure.
Perfect, awesome. Thank you so much, Vint. Before I pass on the mic to Tulio, just a quick reminder to the audience. And if you have any questions for Vint, please send them here on Twitter. Let me just turn on my magic digital high-tech sliding machine, and then
it's a chat bot. That's our chat bot.
This is our high-tech chat bot. Okay. There. You all know how to use Twitter. I don't need to tell you and to hold you by the hand. So send them your questions here on Twitter, and I'll read them back to Vint, and he'll respond here live in real time. So without further ado, Tulio, mic's all yours.
Thanks, Vint. I want to go back a little bit in time with you, but before we do that, I have to ask this question. Actually, it came up by one of our engineers. You put up a picture of the architect from the Matrix, and so I thought maybe you're going to choose the title as architect, Matrix architect. Have you gotten that before? Has that ever come up?
Well, yes, it has. Although, to go really far back in time, I really did feel like the architect of the internet. I mean, Bob Kahn and I, let me make sure that everybody appreciates, Robert Kahn initiated the program when he was at ARPA in late 72, early 73. And he drew me into the program immediately. And together we did the design during 1973 of what is now the internet. So this architect thing was very funny. Those of you who have seen the second episode or second movie, remember there's this guy in a three-piece suit with a beard who was called the architect of the Matrix. And I was on the Stephen Colbert show a few years ago. And during one of the segments, he popped up a picture of the architect and he said, "So are you the architect?" And I looked at Steve and I said, "Steve, what makes you think you're not in the Matrix?" And you sort of, he didn't have an immediate response to that. And I remember his producer said, "Don't say anything funny. You're supposed to be the straight man." But when Stephen put that thing up on the display, and I couldn't, what other answer was there? So I don't know actually whether I was the prototype for that character or not. I mean, there's an awful lot of similarity there. It'd be very hard not to conclude that there was something, but they didn't contact me and ask or anything. So to be honest, I don't know the answer to that.
Thanks for going with us there. So first question I have, what made you choose a career in technology versus anything else in your life?
I was always interested in science and technology, mathematics, and things like that. I remember being in the 5th grade, and I went up to my math teacher and I said, there must be more to mathematics than addition, subtraction, multiplication, division, decimals, and fractions. And he said, "Yes, there is." And he handed me a 7th grade algebra book, which I took home. And over the summer, I worked all the problems. I loved doing them, especially the word problems, because they were kind of like Agatha Christie novels. You had to figure out what's X. And so I was very, very attracted to the mathematics. And then I got interested in chemistry. So at age 10, my best friend and I got a 1953 Gilbert chemistry set. Now, I have to tell you that the chemicals they let you have back then were nothing like what you can have now. We had potassium permanganate, which is hypergolic when you mix it with glycerin, which you could get from the nearby pharmacy. We had powdered magnesium, which goes foof, or powdered aluminum and powdered. Now, we could make thermite grenades. We even made nitroglycerin one time, which is pretty stupid. Fortunately, we didn't kill ourselves. But I got so interested in mathematics and chemistry and stuff like that. So I was sure by the time I was 10 or 11, I was going to be a scientist of some kind. I thought maybe a particle physicist. That sounded pretty cool. And I was reading Scientific American back then without necessarily understanding too much of it. So I was always in that game. Eventually, I got introduced to computers around 1958. The semi-automated ground environment machine, which is running at System Development Corporation in Santa Monica, the tube-based machine. This is how old it was. It was so big that you had to walk inside the machine to use it. The walls were lined with these glowing red tubes. It looked like a scene out of Dr. Strangelove, except Strangelove wasn't until 1962. So I got completely attracted to this. And eventually, of course, I got permission from my best friend, Steve Crocker, to use computers at UCLA while we were still in high school. So we're talking about 1960 or 61 or so. And that just reinforced my interest in computing. So I went to Stanford, did my undergraduate work in mathematics, took all the computer programs I could, went to IBM for work in 1965, ran a time-sharing system for IBM back in those days in Los Angeles. And after 2 years, I realized I needed to go back to school so that I really understood, what's an operating system, what's programming languages, how does a compiler work? And so I entered UCLA in 1967 to do the PhD in computer science. And partway through that program, I ended up working for Professor Leonard Kleinrock, who was the principal investigator for the Arpanet's Network Measurement Center. Now, Arpanet was an early packet switching experiment funded by the Defense Advanced Research Projects Agency. And that cemented my interest in networking. I participated with Steve Crocker again on the design of the host-to-host protocols. I was the principal programmer for software development to measure the performance of the Arpanet and compare that with the predicted performance from queuing theoretic models that Professor Kleinrock had developed and his students had developed. Went up to Stanford after I finished my PhD and started working on network research. And that's when Bob Kahn showed up again for the second time, first at UCLA and now at Stanford, saying, we have a problem. We're going to use computers and command and control. Those machines are going to have to be in airplanes, ships at sea, and mobile vehicles, in addition to fixed installations. We had fixed installations in the Arpanet. These are big, machines in air-conditioned rooms that didn't get up and move around. But computers were getting smaller and smaller, and so putting them on a ship or an airplane or a mobile vehicle was increasingly feasible. So Bob says we're going to have satellite communication and mobile radio in addition to dedicated phone lines to build these networks. How are we going to hook them all together so that it looks like one uniform thing? That was the internet problem. And I just got sucked into that in 1973. We did the original design work, and about 6 months later in September, we had a design. We wrote a paper which was published the following year in July of '74 in IEEE Transactions on Communications. And I spent the entire year of 1974 with a team at Stanford doing the development of the detailed protocols, after which we started implementation in 1975. So, I mean, you can see that I just got drawn into this ambit of networking pretty early on, and I've been with it ever since.
That's amazing. So that was it. That was the birth of TCP/IP. Yes.
That's right. I would say that the conceptual birth comes in 1973. The first complete specifications, the document for that has 3 names on it. It has my name, it has Carl Sunshine, who's now at Aerospace Corporation after many years, and Yogan Dalal, who was the third writer of that detailed spec. Then we started implementation in '75, and we had Bolt, Beranek, and Newman in Cambridge, Massachusetts, and University College London in the UK building the first implementations, and we did 3-way testing between Stanford, BB&N, and UCL. So during that period of 1975, we were discovering mistakes in the protocol or improvements that could be made. We refined this until about 1978 when we standardized on the design and then began implementing on as many operating systems as we could, so that by the January 1st of 1983, we could literally turn the internet on. So that's its operational birth date.
Right. I remember starting in 1989 at MCI, which is where you and I met, and the company used email. I think you were behind that program, and I just assumed every company uses email. Only to learn that wasn't the case. So what was some of the things you learned along the way, moving from what was essentially a government or academia-based environment to a more commercialized internet? What's some of the things that you've learned and that have struck by you during those years?
Well, I can certainly tell you that the group that did the original Arpanet and the ones that did the internet were basically a bunch of geeks. And they were engineers and we're programmers. We are not telecommunications guys. We're computer guys. So we didn't think the same way as the telecom world. And of course, our objective was to just get it to work. We always knew that there was, or I shouldn't say always, but we learned very early that there were social elements to what we were doing. So as an example, during the Arpanet project, which started in 1969, by 1971, a guy named Ray Tomlinson came up with the idea of networked electronic mail. And so we introduced that idea in 71. Everybody went crazy because now we didn't have to be awake at the same time to communicate with each other. You could send a message and have a response at the convenience of the recipient sometime later. So we thought, wow, that will let us manage projects that are spreading over a lot of different time zones, so we could get more, a bigger project done with more people. But the first couple of mailing lists that I remember were obviously social in nature. One was sci-fi lovers, for people that enjoyed reading science fiction and arguing over who was the best writer. And the second one that I remember was called Yum Yum, which was a restaurant review distribution list. So we're immediately seeing a social element to these online computer-mediated environments. Of course, then the World Wide Web shows up in 1991 from Tim Berners-Lee at CERN, and nobody notices, except for a couple of guys at NCSA, the National Center for Supercomputer Applications, and they invent the Mosaic browser, which eventually becomes the basis for Netscape communications products in 1994 and 1995. So we saw this rapid influx of users just from the academic environment using the World Wide Web as a tool for sharing information, which is what it was intended for. By 1989, when you joined MCI, there were 3 commercial internet service providers in operation. One of them was called UUNet, which had started out as a not-for-profit Unix to Unix copy program service, but gradually that shifted over to internet a couple of years later. The PSINet, Performance Systems International Network, which was constructed based on the an academic network, assets of an academic network in New York called NYSERNet, the New York State Education and Research Network, which had been funded by the National Science Foundation, which, by the way, in 1986 had funded the NSFNet backbone and a bunch of intermediate level networks to connect 3,000 universities together. So by the 1986 period, 3 years after we turned the internet on formally, we're seeing the academic community growing rapidly in the United States. With the commercialization of the internet starting in 1989, now we started to see a whole new cast of users show up, dramatically increasing as the World Wide Web appears and Netscape Communications makes its offerings available, and other browsers and web server technologies begin to occupy the internet backbone. The network continues to grow at as much as 100% a year during those early 1990s and even into the 2000s. So what do we see now? Well, the big side effect of allowing the general public on the internet is that you get all the good and the bad aspects of humanity are there visible in the internet. It's like a big mirror of our global society. And of course, some of the things we see in the mirror we don't like. So we see abusive practices using this otherwise neutral platform to potentially harm other people or to fool them, to commit fraud, to put up bad information or false information, to spread malware around the network, to launch phishing attacks and denial of service attacks. So what we're seeing is an infrastructure which is spread very rapidly, which companies that are operating it have found business models that make it sustainable. But now we're starting to see abusive practices, and countries are starting to notice that this is an issue. Their citizens are potentially at risk, and so they want to do something about that. So there's international dialogue about internet governance and the question of how we protect people from bad actors. It's like every other law enforcement problem. First, we have to have laws that say, these behaviors are unacceptable, and if we catch you doing them, there'll be consequences. You also have to figure out how to catch the bad actors. And because this is a global system, there is going to be the problem of international collaboration among the countries in order to catch parties who are harming others on the net. So the big tough challenge we have right now is to invent technology that inhibits or at least diminishes some of the bad things that can happen, whether that's the use of cryptography for privacy or the use of sophisticated methods to detect and inhibit denial of service attacks or hacks against the domain name system, or even to put laws in place that allow countries to cooperate with each other to track down bad actors, or even just to tell people don't do that, it's because it's wrong. And although that sounds kind of wimpy, when you think about gravity, it's the weakest force in the universe. And yet, when you get big mass, it's a very powerful force. So when you get a large enough chunk of humanity or chunk of a given society saying, we don't accept these behaviors as acceptable in our society, that's social pressure reinforced by law enforcement can make quite a big difference.
So what do you think about things like blockchain and AI? Are those going to assist with some of these challenges?
Well, let me start with blockchain, which of course is in a hyperbolic period of its existence. At least the hyperbole about it is extraordinary. I think that blockchain has some utility. It has some limitations. The rate at which blocks can be formed, for example, can be an inhibitor to use it for high transaction rate recording of purchases and sales and other things. It's also in the form of Bitcoin, for example, or other cryptocurrency value systems. I think it can be misleading in the sense that it isn't clear what those cryptocurrencies are worth in any intrinsic sense. They have value because they have a kind of an auction value to them, but that's a highly volatile potential. I think that in the United States, the IRS is treating investments in Bitcoin or other cryptocurrencies as a speculative commodity. So I think we should be very skeptical of the broad claims that are being made about blockchain. It's a distributed ledger. It's a distributed database, and it under certain circumstances might be very attractive. In other cases, it might not be suitable because of the rate at which you can handle transactions in the blockchain. So I'm still kind of skeptical about the cases where blockchain will work well. Anonymous blockchain still leaves you with the uncertainty about who are the parties who are maintaining the information that you're relying on. I kind of like the permission blockchain where I know who they are. So I think that we should be very thoughtful and careful about how we choose to use blockchain and what we sell to other people about its utility. Now, you mentioned AI, and that, of course, comes in many flavors. The historically interesting AI was really about general artificial intelligence. That is to say, software systems that can reason about the real world, reach conclusions, make observations and the like, and have a deep semantic understanding of the world. I would say that we're still quite far away from that. But machine learning is a very special and narrow kind of artificial intelligence, where training with a bunch of images, for example, allow the system to distinguish one image from another. In medical applications, it might let you tell cancerous tissue from non-cancerous tissue, for example. We should just be very careful about machine learning and multi-layer neural networks because they appear to be very smart in what they're capable of doing. On the other hand, they often go clunk when, for example, confronted with a piece of information that they haven't been trained for, and they guess wrong, for example, or they make wrong recommendations or wrong recognition. So, for example, you can train a multi-layer neural network to distinguish cats and dogs, and you can do very well with that until somebody comes along with a picture of a cat and changes 3 or 4 pixels in the image, and we look at that and it still looks like a cat. But the machine learning system may have used those 3 pixels as the decision factor between cat and dog. And if the values change, the hyperplane that divided the cats and the dogs suddenly shifts, and the next thing you know, the cat looks like a dog or a warthog or something else. So we have to be careful about those systems because they're brittle and they can be wrong. And we want to be careful not to assume that just because they were trained on some cohort of data, that somehow we'll always get the right answer.
Thanks. I want to ask a question about how we get beyond 50% penetration or adoption. Before I do that, there's a question from one of our guys, Victorina. He said, so we know what the internet has become. Was there some kind of a draft plan or vision for what it was intended to become? Can you elaborate on that a little bit?
Absolutely. There were several different contributing visions of this thing that reach all the way back to 1945. The first article that is relevant to what we've ended up with is called As We May Think by Vannevar Bush, who was also the person who started the National Science Foundation and was the first science advisor to Harry Truman. And in that vision, As We May Think, Vannevar Bush thought of a thing he called Memex. And he was using technologies at the time. There were microfilm, for example, and he had the idea that, excuse me, somehow or other, you could query this Memex, which is full of microfilm, and it would come back and pull up the appropriate information for you. So he had the primitive idea of search engines, if you like. Then around 1962, J.C.R. Licklider at MIT was a psychologist, had the notion that computers could be used for non-numerical purposes, like communication. And so he wrote a letter to a bunch of his friends saying that he wanted to talk to them about the intergalactic network. And of course, that was tongue-in-cheek. But he wanted to link computers together in order to allow them to be used in a collaborative way. Douglas Engelbart was one of the parties sponsored by or supported by Licklider when Licklider became the first director of ARPA's Information Processing Technology Office. So Engelbart is the guy who developed an online document production system called NLS for online system. He had to invent a mouse, the thing that we call a mouse. He had to invent that to point at places in the screen and say, I'm going to edit that part of the document, so click here. Or I want to go to that other document that's referenced here with a hyperlink, which should sound familiar to people who know about clicking on hyperlinks in HTML and in typical World Wide Web terms. But this was way back in the 1960s that Engelbart was doing this work at SRI International in Menlo Park, California. So this was the work that was done on the Arpanet and eventually on the internet was informed by all of that. A lot of heavy academic use, a lot of knowledge sharing, the ability to compose documents together, to click on references back and forth to them, was all part of that early thinking. Of course, as the internet comes along and as we get the World Wide Web in the early 1990s, we begin to see a vastly easier way of composing and sharing information. We get situations like we have at Google where the Google Docs can be edited simultaneously by multiple parties, which I still think is pretty astonishing. Or maybe it's a presentation or it's a spreadsheet or something else. So we've come a long way in our ability to harness computers for collaborative work, which is what Doug Engelbart always thought was a very important way for us to improve our wetware up here by adding intellectual power from computers used in this fashion.
So we're 50% there in terms of penetration of the world of the internet worldwide. What's holding us back from getting to 100%? What's happening and what's being done about it?
So let me take you back to the early days of internet for a moment to set the stage. When Bob and I started the work, we had to decide things like, should we apply for a patent? And I think actually software patents weren't allowed in 1973, so the answer was no. But we had a different reason for not wanting to patent anything. We didn't want there to be any barriers to the use of the technology. So we basically just gave it away. And that was deliberate because we wanted people to adopt the use of this technology, because the more people that did that, the bigger the system could be. we anticipated that it would be global in scope because it was being designed to support U.S. military command and control, which has to work everywhere. It has to work with allies. And we couldn't predict who our allies were going to be 25 years from then. And so we said, we'll have to give it to everybody because we don't know who are our enemies and who are our allies over a period of 25 or 30 years. So the idea was that if people would adopt the use of the technologies and build a network based on these principles, that it would interwork with other networks. And so the whole system could grow organically. We didn't dictate any business model. So we said, you know, you can use whatever business model works for you. It could be a not-for-profit organization getting grants from the government. It could be a for-profit company. And, you know, literally any business model that worked was acceptable. And that's part of the other rationale for just giving everything away. In the end, we hope that people would build pieces of internet and then find somebody to connect to. And if they did it right, everything should interwork. So that was really our thinking in the earliest stage of this system. We had hopes that the system would spread broadly around the world, and indeed it has.
Tulio, if I may, real quick, we were about to, I'm hearing some echo, that's why I got a little distracted, sorry. Okay, so we're about to approach the final segment, the final minutes of today's conversation. And I know that we wish we had all the time in the world, but what I'd like to do now, just real quick, is to remind the audience that if you have any questions for Vint, I mean, if you're watching out there in the world, not from the earshot, just send them your questions right here on Twitter at DojoLIVE. This is where you can send us your questions. Just go here and submit them, and we'll read them back to Vint right now. And with that being said, Tulio, we're about to wrap up today's session, but I'll let you take the lead on that. Thank you.
Yeah, thanks. So Vint, so let's fast forward now. Okay, we got a good history. What's this plan behind 2020? What's happening in 2 years?
Okay, so let's look at, first of all, I mentioned earlier all of the challenges we have with policy and internet governance and the like. This is going to occupy a lot of our time. You can see it, the headlines now, fake news and all the other things that we are troubled by. Bullying, for example, this is a recent topic of considerable concern. So we have a lot of work to do about the sociological effects of and abuse of the internet, while at the same time trying to preserve all of its incredible value, which is finding information that we care about and want to use, or sharing information that we want other people to use. So that's going to occupy a lot of attention in the 2020 and following period. Second, we're seeing, of course, a rapid spread of mobile use on the net. And we're also starting to see a tidal wave of programmable devices that fall into the Internet of Things category. And that too is going to be a big challenge, because if you have 100 or 200 of these devices at home, figuring out how to manage them, how you assure that they can be updated if there's bugs in the software, how you can resist a download of a piece of malware into those devices, how you avoid having them abused. I mean, I used to worry about a headline that said 100,000 refrigerators attacked Bank of America. Well, that hasn't happened, but there was another headline that said 500,000 webcams attacked Dine Corporation. And it's a real issue here because the webcams are IoT devices that had no access control. So somebody was able to build a botnet out of those webcams and have all of their million bit per second video streams aimed at the same target. That's 500 gigabits per second of traffic, which of course knocked Dine Corporation over, understandably. So we have those issues have to be dealt with. We have to deal with scaling of IoT and how things get configured. How do you talk to 100 different light bulbs in your house to get them to turn off and on? Do you have to give them names like Fred and George and Harry? If you have guests coming over, do you have to introduce them to the light bulbs? I mean, there are a whole series of challenges associated with automation in the residential or business and office and industrial setting. So that's going to occupy us. Then there's the interplanetary extension of the internet. And it is scheduled to become quite more visible during the 2020's period, because most of the spacecraft that the US will launch may very well carry the interplanetary internet protocols on board, so that they can be supported for manned and robotic exploration, but also repurposed eventually as nodes of an interplanetary backbone to support manned and robotic exploration. So those are quickly the various things that are happening in the foreseeable next decade or so.
Wow, we got a lot to look forward to. So one final question, then I'm going to pass it back to Carlos to wrap up. What excites you about what's next?
I think what excites me more than anything is that I think only about 1 or 2% of all the possible applications have already been invented for the internet. We're seeing this beautiful, wonderfully malleable, evolving and changing platform, absorbing new capacity, new technologies, supporting new applications that are limited only by people's imagination. And so there's nothing more satisfying than feeling like you've created an environment where that kind of inventive and creative energy can find purchase and continue to serve all of us, we hope, in ways that are positive and constructive.
That's fantastic. I'm going to squeeze one last question from one of our people, Judith Garcia. So let's imagine all those challenges resolved, fixed, working. How do you think this will change the human interaction?
I'm sorry, how it will change?
How do you think it'll impact human interaction with each other?
Well, what I hope is that it will make almost transparent our ability to work with each other, to collaborate, to share information, to get access to each other's knowledge in a convenient way, and maybe harness computing cycles so that our wetware can be augmented by those computing cycle software and empower us to do things that we couldn't do as individuals, or couldn't even do as groups of humans, because the computer has such capacity to do things that we can't do with our own brains, although we can do things that those machines can't do. And so it's the collaboration between the two that should be really powerful.
Ben, thank you so much. I enjoyed this tremendously. It's always a pleasure talking to you over the years. You've been a tremendous source of knowledge for me. Carlos, back to you to wrap it up.
Thank you so much, Tulio. Ian, well, I think in wrapping up, I think it's, I have one more question, actually, by the way, from Matt Perez, one of Nearsoft's founders. And Matt is asking, Vint, what is your biggest disappointment relative to how the internet has turned out?
Well, I think the biggest one is that, and it's an understandable one, is that this essentially neutral platform has created the temptation for abuse. And it's an unfortunate observation about the human condition that not everyone has your best interests at heart. And I guess that's not a disappointment of the internet as much as it is a disappointment of the people who use it or abuse it. And it just tells us that we have to be on our guard to recognize that that is a problem, and we have to devise ways of diminishing that potential hazard, while at the same time preserving all the enormous value of access to information and our ability to discover people of common interests and people who wish to work together for constructive reasons.
Well, thank you so much, Vint. And there you have it, Matt, from the man himself, Vint Cerf. And well, unfortunately, all good things have to come to an end. So, Vint, the only thing left for me to do is, well, first of all, here's a big, heartfelt, warm thank you for having shared your wisdom, your time with us and with our audience. And if you're watching out there, and if for some reason you happen to have missed most of Vint's interview, it's going to be right there on our DojoLIVE website, which is dojo.nearsoft.com. Just go there and find it. It's, it's very easy. You can't miss it. And without further ado, without further ado, I need to wrap up today's session I need to ask you one more thing, Vint. If you were to leave our audience with some final words of wisdom, what would these be?
Don't be afraid to try things out. Risk is okay. Failure is okay, as long as you learn from it. That's how we make progress.
Perfect. Awesome. It doesn't get any better than that. So thank you so much, Vint. Thank you, Tulio, again. And thanks, everyone, for watching today's interview. And before we go, and just a quick announcement for next week, actually. And we're going to be having another interview, another DojoLIVE interview with Darren Harpaz, founder and CEO of the Zenith Group. Okay, so just keep an eye on that. Wednesdays, 3 p.m. Central Standard Time with Darren Harpaz, founder and CEO of the Zenith Group. And it's all right there on the DojoLIVE website.
Great.
Okay, so Vint, thank you so much. It was an honor.
Thank you, Vint.
Goodbye, everyone.